Hello, and welcome to Backer Breaks It Down. We continue looking at triangle similarity in this episode, with a focus on using scale factor and proportions to find missing segment lengths in triangles. So let's check out an example. Okay, remember, when two triangles are similar, their corresponding side lengths are proportional. So we're going to create a proportion using these corresponding side lengths. Now it's already been done for us, so let's take a look at what exactly they did. So here they have VW over VY, okay? And so notice what this is representing. So VW is a side of our smaller triangle, triangle VWX. And VY is the corresponding side of the larger triangle VYZ. So the way these ratios are set up is you've got a linear measurement from triangle VWX on top and the corresponding linear measurement from VYZ on the bottom. Okay, so that's the pattern we're going to maintain. And so on the other side, they have WX over YZ. WX is the side of our smaller triangle, and YZ is the corresponding side of that in the larger triangle. So that's how they're getting this proportion here. And then from there, you simply cross multiply, divide, and you get that A is 9. Okay. So let's check out this one. We're told the triangles are similar. We need to set up and solve a proportion to find the value of the variable. Okay. So let's create a proportion where on top, we have a measurement from triangle AEB, and on the bottom, we have the corresponding linear measurement from triangle ADC. Okay, that's going to be my pattern. So let's take a look at triangle AEB. What are the measurements there? Well, clearly one side is x plus 2. And what's another side of triangle AEB? Okay, so that'd be this one right here. How long is it? That's correct. It's 3 because the whole side is 8. That part would be 3. So here are my sides from triangle AEB. So now underneath that, I want to write the corresponding sides of triangle ADC. So what corresponds to x plus 2? Okay, be careful here. Make sure you're using the whole side. I actually want to add these pieces together and get x plus 8 because that's the corresponding whole side of triangle ADC. And what about the other one? That one is indeed 8. So here's my proportion. Everything on top comes from triangle AEB, everything on the bottom from triangle ADC, and the two ratios represent corresponding sides. So I've already gone and I've solved this. So I cross multiplied, divided, and I got that x is 1.6. Okay, but make sure you're using the whole side because it's really easy for students not to do that. Okay, so what about number 2? Okay, clearly in the diagram, we see that AB is 3 and FE is 8. Furthermore, they told us that BD is x minus 1 and CE is x plus 2. Okay, so I can create a proportion where it's ABC over FEC. Okay, so I'm going to write the side lengths from triangle ABC, which is a typo. Wow, I'm awesome. It should be ABD. Sorry about that. So I'm going to write my side measurements from ABD on top. So I'm going to have 3 over, and then this is going to equal x minus 1 over, and then I want to write the corresponding sides from FEC on the bottom. So AB corresponds to the side measuring 8, and BD corresponds to the side measuring, corresponds to CE, which is x plus 2. So this would be my proportion. I would cross multiply to solve. And I did that, and I got that x is 2.8, okay? So the triangles are similar. Complete the similarity statement, then set up and solve a proportion to find the value of the variable, okay? So in a diagram like number 3, you want to be careful, like, because you want to make sure that you are like matching up the right corresponding sides. So I've got my vertical angles, of course, which I know are congruent. And then those red arrows are indicating that like the sides are parallel. So then I have like alternate interior angles that are congruent, okay? So I can create a proportion where I have triangle JGH on top. What would be the name of the triangle that it's similar to? So J and F, I now know are congruent. G is the vertex of our vertical angle, and then E. That similarity statement might help you in setting up your proportion. Okay, if you're getting a little twisted looking at the diagram. Okay, but I can put the two side lengths from triangle JGH on top. So I've got 20 over 15. Now notice 20 is JG, and according to my similarity statement, JG corresponds to FG. So that would go below the 20. And then HG corresponds to EG, so 2x minus 2 would go underneath the 15. So here's a proportion that shows the corresponding side relationships that are proportional between our two similar triangles. Then we would cross multiply and solve. I ended up with x is equal to 7. Okay. And then in number 4, we are given that angle H is congruent to angle RDO. Okay. We are given that RD is 4 units long, that RO is 6 units long, that OH is 4 units long, and we want to find CD. So first off, do you see your two triangles? Okay, clearly we have this smaller triangle, and then we also have the bigger triangle. So if I outline them like this, what do you notice? That's right. They both share angle R. So the two triangles are similar by angle. This is also going to help us write our similarity statement, okay? Because angle C, well, that's the only angle I don't have like any markings on. That's the same as this angle here with vertex O. And then H, I have that red singular arc mark. That's what I have on D. And then R, of course, is that shared angle. So this similarity statement is going to help me write my proportion. I can put measurements from triangle CHR on top and measurements from triangle ODR on the bottom. Okay, so I'll have a ratio is equal to another ratio. So let's take a look at these two triangles. So CHR. Notice that one side of CHR is made up of 4 and 6 units, so a total of 10. And then the other side of CHR is made up of the segment that's x and 4. So this would be like x plus 4, okay? Now I want to write down the corresponding side lengths beneath those, okay? So let's be careful here. So the 10 came from side HR. So when you look at your similarity statement, HR are the second and third letters. So they correspond to DR, and we know that DR is 4. The x plus 4, that's side CR. CR, your first and last letters. So that would correspond to OR, which is 6. So here's our proportion. And then we would simply cross multiply to solve. I ended up with CD is 11. Okay. And so that's how we use the fact that corresponding side lengths in similar figures are proportional, okay? So when you go to write your proportion, you want like each ratio to show a relationship. You want the top values to have a relationship, same with the bottom values. So I think the easiest thing to do is to use your similarity statement and be like, okay, I'm going to create two ratios, like where triangle DEF is on top and triangle MNP is on the bottom. So that's just like a good strategy. And that is how Thacker breaks it down.